All right, guys, next rule, 12, 30, 34, maximum number of insulated conductors in a box. Let's start off with 12, 30, 34, 1. So this number 1 says boxes shall be of sufficient size to provide usable space for all insulated conductors contained in the box. So a key word there is insulated. So you'll see when I start going through bonds and stuff like that, an insulated bond conductor actually counts for box fill. If you have a bare bond, it doesn't count. Okay, so the main word here is insulated for 12, 30, 34, number 1. Okay, for this rule, 1A, an insulated conductor running through a box with no connection shall be considered as one insulated conductor. So here we've got a red, a black, and a blue. I'm not saying what gauge or anything, we're just saying that they're running through the box. So each of these guys are going to count as one conductor. So we have a total of 3 conductors in terms of box fill if it's going through the box. Okay, so each conductor that goes through the box counts as one conductor. Okay, 1B, each insulated conductor entering or leaving the box and connected to a terminal or a connector, meaning like a switch or receptacle for a terminal, or a connector being a moret, within the box should be considered as one insulated conductor. So here I've got the same 3 wires that we're going through. Each of these guys are counting as 1. This wire right here, because it's an insulated conductor, counts as 1. And this one right here that's leaving the box counts as 1 as well. Okay, so insulated conductors going in and out of the box count as 1. So in this case, we're going to have 1, 2, 3, 4, 5 conductors. We're going to talk about the fact that this pigtail does not count and this single moret does not count. So at this point, we have 5 conductors, 3 going through and 2 coming in and out. Okay, so that's covered under 3034 1B. Okay, next one, 1C. Insulated conductor of which no part leaves the box should not be counted. So pigtails, being for the hot, the neutral, and the ground here, they don't count whatsoever. This pigtail right here, bonding to the box, does not count whatsoever. It's the conductors that are coming in and coming out of the box that are going to count in terms of box fill. In this case, I neglected to put the other bond conductor here, so we would have 1, 2, 3 coming in, and then 1, 2, and it should be another third bond coming out. So 6 conductors. Then we're going to have to talk about the rule in terms of morets and then how much this receptacle is. We'll get there in the next couple slides. Okay, so for this one, if the conductor is not leaving the box in terms of being pigtail, it doesn't count for a box fill. Okay, same rule, 3034 1C. Just the same thing, we'll just have 3-phase here. Obviously these guys aren't going to be like this, or we're going to connect it to a 3-phase plug or something like that, so we'd have to talk about the 3-phase plug and the size that it takes, but in this case, these 3 pigtails would not be counted in terms of box fill. Okay, 12, 30, 34, 1D. Number 18, number 16 gauge fixture wire supplying a luminaire mounted on the box containing the fixture wire shall not be counted. So if you have a light fixture and the conductors coming from the light fixture are number 16 or number 18, they don't count whatsoever. They're too small. Okay, so take a look at 12, 30, 34, 2. Number of conductors shall be reduced for each of the following conditions as applicable. So we'll go through A, B, C, and so forth. Let's start with A. One insulated conductor of the largest size. That's key, guys. It's got to be the largest size. So if you have number 12s, number 14 in a box, obviously each of these guys, being a fixture stud or a hickey, is going to count as the largest size. In that example that I just gave you, it would be a number 12 for the largest size of conductor. Fixture stud is one of these guys right here, and a hickey is this guy right here, normally used for mounting of chandeliers. Okay, let's take a look at B. Oh, sorry, one more image here of hickeys and studs. So this would be a fixture stud right here, and then hickey looks like this. Okay, so obviously they're taking up, surface area within the box, so they have to be counted for box fill. Okay, B, this is for the morets. So the number of conductors shall be reduced for each of the following conditions as applicable, 12, 30, 34, 2. 2B says one insulated conductor of the largest size, always the largest size, terminated under a conductor connector for each pair of conductor connectors with insulating caps. So each of these guys has to be a pair in order to count as a conductor. Again, the largest conductor in the box there. So 1 moret, nothing. 2 morets, that's obviously a pair, that's 1 conductor. If we've got 3 morets, that's only 1 pair, so that's still 1 conductor. Once we go to 4 morets, we've got 2 pairs, so that'll count as 2 conductors, and then so on and so forth. If we've got 5 morets, then we've got 2 pairs, so that's also going to count as 2 conductors of the largest size in the box. Okay, 1230-34-2C, 2 insulated conductors for each flush-mounted device on a single strap, i.e. single gang within the box. So if we have a receptacle, or we've got a standard switch or a Decora switch, each of those guys are going to be counted as 2 conductors, right? They're taking up quite a bit of surface area, so they're going to count as 2 conductors in the box. Okay, next rule, 1230-34-3. So with these guys, they're just standard sizes, right? With these receptacles or Decora receptacle. Once we get into a GFCI that takes up more room, then we're into the next rule, 1230-34-3, where a box contains a device having a dimension greater than 2.54 centimeters between the mounting strap, this guy right here, and the back of the device. The total usable space shall be reduced by the space occupied by the device, calculated as 32 centimeters cubed, multiplied by the depth of the device in centimeters. So I've got this example here for this GFCI. Looking it up in the spec sheet, it's 41 millimeters or 4.1 centimeters. So the occupied space that this bad boy is going to take up is 4.1 centimeters times our 32 centimeters cubed. So this unit right here can be expected to take up a volume of 131.2 centimeters cubed. Each of these rules we're going through are going to have examples in the rest of the video here, guys. So we'll look at a GFCI within a device box and see what size of box, what size of deep box that we need in order to accommodate that 131.2 centimeters cubed. Okay, next one, guys, 1230-34-5. Total usable space in a box considered under Table 22 shall be considered to be the internal volume of the box and shall disregard any space occupied by lock nuts, bushings, box connectors, or clamps. So lock nuts, bushings, box connectors, or clamps, they're not going to count in terms of box fill. Okay, they've already, like in terms of this box, these clamps have already been accounted for within the volume that they've provided for the box there. Okay, 1230-34-6, where sectional boxes are ganged. So when you're taking a gangable box, removing the side, and then putting them together, or where you're using plaster rings, or extension rings, or raised covers used in conjunction with boxes, ganged or otherwise, and are marked with their volume measurement. The space on the box shall be the total volume of the assembled sections. So when you're doubling these guys up, you're doubling the volume of the unit. Once you put it on an extension ring, you're providing the amount of volume that size of box is going to provide you, in addition to your standard box. And then if you've got a mud ring like this, then it'll provide you with the volume. In this case, it's 58 millimeters of additional box space for this portion of the mud box. Okay, so you're just adding up all the volumes that are provided there and making sure that there's enough volume for the conductors that you're putting in there. Okay, so out of the ones that we've looked at so far, 1230-34-1A, each insulated conductor running through a box is going to count as 1 conductor. 1B, each insulated conductor leaving a box that's wired to a terminal or connector is 1 conductor. Entering or leaving is going to be 1 conductor. And for those 2 rules above, if the bond wire is insulated, it's going to count as one of those conductors. 3034-2A, 1 or more fixture studs or hickey is going to equal 1 conductor. 2B, each pair of wire connectors is going to be 1 conductor. So it's a pair of wire conductors, so 1 Moretz, nothing. 2 to 3 Moretz is going to be 1 conductor. 4 to 5 Moretz is going to be 2 conductors, obviously of the largest size. 1230-34-2C, switch or receptacle on a single strap is going to be 2 conductors. And then if we've got something large, like a big timer or a GFCI that takes quite a bit of depth, if the device has a depth greater than 2.54 centimeters, total usable space has to be reduced by the actual space occupied by the device. So depth of the device times 32 centimeters cubed. Okay, so those are all the rules for conductors, which is key, I haven't mentioned this yet, that are number 6 and smaller. Okay, so conductors that are larger than that, like when you're doing pull boxes and stuff like that, different rule completely. Now we're talking about like device boxes, octagon boxes, and square boxes. Okay, those are all items that count for box fill for conductors that are number 6 and smaller. The ones that you can neglect or negate are any conductor. So 1C is any conductor that originates and remains in the box, i.e. pigtails, counts as nothing. Number 16 and number 18 fixture wires counts as nothing, that's 1D. And then 1230-34-5, lock nuts, bushings, box connectors, and clamps, they all count for 0 conductors. The 2 box fill tables we're going to be looking at in the examples that follow are going to be Table 22, space for insulated conductors in the box, and Table 23, number of insulated conductors in the box. Okay, so let's take a look at a number of examples here, guys. So we'll start off with the first one. as we go through these guys, you can stop the video, see if you can find the answer on table 22 or 23, whichever is applicable, then restart the video and see if we came to the same conclusion. If I made any mistakes, you will see them in the comment section right away. Okay, first box example, guys. Determine the size of box to accommodate 3 number 10s, AWG, and bonding is achieved through the EMT. So in this case, I don't have a bond conductor. I'm saying that the bonding is being provided through the EMT, the metal box, and the other box connector and EMT. And obviously these conductors are pulled straight through the box. And I'm going to be looking for a type of square box that accommodates 3 number 10s. Okay, so stop the video here, see if you can figure out which one it is, and then I'll bring up the answer. Okay guys, let's bring up the code. We'll bring up table 23 here. So we need 3 number 10s. We're going to size of square box to accommodate those guys. So we're going to table 23 here. Let me erase some of the stuff I was working on earlier. We need number 10s here. We're looking at square boxes here. And we're going to need how many? We need 3 that are pulled right through, right? So each of those guys are going to act as, or count as, one conductor. So we need 3 number 10s. So obviously we can see here that a 4 by inch and a half square box is definitely going to be large enough. 4 by inch and a half square box is going to be able to accommodate 9 number 10s. So we'll easily accommodate the 3 number 10s that we have pulled straight through the box there. Okay, so, and again, you can, if you have the PDF, you can bounce back and forth between table 23 and the rule 1230-34. Okay, hopefully everybody was good with this example. Let's move on to the next guy. So we'll bump up the conductor size. Okay, so next one is determine the size of square box to accommodate 3 number 6s. So again, we're pulled straight through, so each of those guys is going to count as 1. We need number 6s now. So let's go back to table 23. Let's erase what we had there before for the number 10s. We're going for number 6s now, and we need 3 of those bad boys. So we're going down until we find a box that accommodates that. And it looks like the exact same box, the 4 by inch and a half, is going to be able to accommodate both the 3 number 10s that we pulled through, or the 3 number 6s that we pulled through there. Okay, so conductors that are being pulled through are obviously going to count as 1 conductor each. Steps are to go to table 23, find the conductor size, and then move down until you see a box that accommodates the number of conductors that you have pulled through that box there. Okay, let's move on to the next example, guys. Okay, next example is going to be the same 3 number 10s, but instead of being pulled straight through, these guys are going to have joints in there on each conductor. So there's a number of rules that are going to come into play here, right? So we have entering and leaving, so we've got 1, 2, 3, 4, 5, 6 conductors, right? So we've got 6 number 10s. Then we've got a pair of Moretz. We have 3 Moretz, obviously, but the pair is just going to act as 1, right? So 3 Moretz is going to act as 1 of the same gauge, number 10s. So in this case, we have a total of 7 number 10s. So if we bring up table 23 and we're looking for number 10s, let's erase what we had before there. We're in number 10s here, and it looks like the same box, so 4 by inch and a half, is going to accommodate those 7 number 10s, right? Because obviously we said in the previous example that the 4 by inch and a half square box has enough volume to accommodate 9 number 10s. Okay, so a couple rules there. We were looking at the pairs of Moretz counts as 1, and then each conductor that comes into the box, 1, 2, 3, 4, 5, 6, counts as an individual conductor there. So a total of 7 number 10s, and then we went to table 23, and we can see that in table 23 that the 4 by inch and a half box accommodates 9 of those bad boys. Okay, let's do the same example, but we're going to bump up the size of conductors. So we're going to go with the number 6s again. So we're looking for size of square box that accommodates these number 6s, but there's joints being made on the number 6s as well. So we already know the number is going to be 7 conductors, right? So again, we've got each conductor entering or leaving, so 1, 2, 3, 4, 5, 6. Each pair of Moretz is going to count as 1. So we've got a total of 7 number 6s. And if we go to table 23, okay, so we're looking at the number 6 column here, and we're scrolling down. We're going to see if we can find a value that accommodates, how many do we have? 7 number 6s, right? So we got to come down here, and this isn't going to cut it, right? The 4 by 1.5 inches is not going to cut it. The 4 by 2 1/8 is not going to cut it either. It only accommodates 6 number 6s. So we're going to have to go with, this one's not going to cut it either, 4/11/16 by 1.5 inches. We're going to have to go to the largest size box there in terms of square boxes. It accommodates 9 number 6s. So the 4/11/16 by 2 1/8 box is our square box that's going to accommodate the 7 number 6s that we have in this example here. Okay, so hopefully everything's making sense so far. We've looked at conductors that are being pulled through the box, and now if we have joints, then each conductor that comes in counts as 1, and each pair of morettes counts as 1 as well. Okay, then going to table 23, finding the appropriate column, in this case number 6, and then finding a box that provides the amount of conductors that we're looking for. In this case, we're looking for 7. So 4/11/16 by 2 1/8 is our minimum size square box that we can use for those conductors there. Okay, let's take a look at another example here, guys. Okay, so again, you're stopping the video when each of these examples are brought forwards, and then restart, and I'll show you the answer. So in this case, this is one that I was alluding to before, that we're going to look at this example. On the previous one, we're looking at code rules and pigtails. I just had the single receptacle, but we've added a switch into this box here. So we've got one receptacle, one single pole switch, and we've got joints, and the conductor size is going to be number 12s. Okay, so we're looking for the size of square box that can accommodate these guys. So stop the video here, see if you guys can figure this out in terms of the rules that we've already talked about, and then I'll put the answer on in a couple seconds. Okay, so for this one, each conductor entering or leaving the box is going to count as 1. So we've got 1, 2, 3, 4, and then 5. There's 5 conductors that are either entering or leaving. In this case, I have not brought a bond through in order to bond everything. We're saying that the bonding is done through the EMT. So the receptacle is bonded to the box here. So again, we got 1, 2, 3, 4, 5 conductors that are either entering or leaving the box. The receptacle and switch are going to count as 2 each. So that's 4 number 12s. And then we've got a pair of morettes here, so that's going to count as 1 conductor. So we have the 5 conductors coming in and out, 6, 7 for the switch, 8, 9 for this receptacle, and then 1 more for 10 as a total for this additional pair of morettes there. So we need 10 number 12s. Let's take a look at table 23. And for table 23, we're looking at number 12s here. So we're in the number 12s, and we need 10 of those bad boys. So it looks like that original box, the smallest box, the 4 by 1.5 inches, is going to be able to accommodate both the switch, the receptacle, and the joints that we made on those number 12s there. Okay, so hopefully everything's making sense on this example here, guys, and you're getting the groove here on figuring out box size in terms of the rules that we have in 12, 30, 34. Let's take a look at the next example. I got 11 or 12 examples for you guys. So boxville example number 6. So for this guy, we have a device box now. So we're going to go to a different portion of table 23 for device boxes. We have a receptacle, and we have obviously 3 morettes. In this point, I have a bare bond conductors. The bare bond conductors coming in. So keep in mind that those bare bonds are not going to count in terms of box fill. So our conductors coming in and out, we're going to count. Pairs of morettes are going to count, and the receptacle is going to count as well. So let's stop here, guys, and then you guys find the answer, and then restart the video, and I'll show you the answer on table 23. Okay, so on table 23, we're going to look at like total number of conductors. So each conductor entering or leaving the box. So 1, 2, 3, 4 conductors entering or leaving the box. The bare bonds do not count. Then the receptacle is going to count as 2 conductors of the largest size. In this case, we have number 14s. And then every pair of morettes is going to count as 1. So 1, 2, 3, 4 for the wires coming in and out, 5, 6 for the receptacle, and then total of 7 because we have 1 pair of morettes there. So let's take a look at table 23 and see whether we can find the size of device box there. So we're in a different portion here. Let's go to device boxes here. We're in number 14 gauge wire, and we just need 7 of those bad boys. So this are not going to cut it. Looks like this is the smallest box that we can make use of. So we're going to look the minimum size box that we can do in order to accommodate this receptacle and these joints is going to be a 3 by 2 by 2.5 device box. Okay, so in that case, we needed to have space for 7 number 14s, and this is just going to make it. It's got the volume for accommodating 8 number 14s. Okay, let's take a look at the next example, guys. So in this example, we've made use of morettes and made some joints to have the conductors keep going. On the next example, we're going to have the conductors come in, and we're going to go to the terminals of the receptacle in order to have those conductors keep going to this next NMD 14.2 below. So bond is still uninsulated. We're still using standard Romex here, but instead of doing the joints here with the 3 morettes, we're going to the actual device here. So with this one, again, we're going to table 23, conductors entering or leaving the box. We've got, again, 1, 2, 3, and 4, right? We've got 1 moret here on our bare bonds there. So that's going to count for nothing. The ones that come in and out, we've got 4 conductors, and the receptacle we saw in the previous example equals 2 of the number 14, largest conductor in the box. And so obviously we've got a total of 6 number 14s, and we want to see what type of device box. So if we take a look here, let's erase our previous stuff here. We're looking at number 14s, and we need 6 of those bad boys. So in the device box unit, it looks like this guy is going to just do it. So minimum size box is going to be a 3 by 2 by 2 device box there. And we can see that it just accommodates the 6 number 14s that we're looking for there. So on the previous example, if we go back to the previous guy, we need to have a 3 by 2 by 2.5 to accommodate the 7 conductors. Now that we are down to 6 conductors, we can get away with a smaller box there, 3 by 2 by 2. Again, all of these examples, guys, are the minimum box size required. Okay, so obviously it makes a difference if you're making joints or going to the terminals on the device there. Okay, reducing the size, the number of morettes. Okay, let's take a look at a GFCI, guys. So GFCI in this case is 4.1 centimeters in depth. We're going to have 1 moret for our bare bonds. I'm going to make the connections on the actual terminals of the GFCI. So we have our line side coming in, load side coming out. And let's try and figure out the size of box that it can accommodate this guy here. Remember that because this is GFCI and it's larger than a standard receptacle at 4.1 centimeters in depth from here to the back of the device, we're going to have to make use of the other code rail. So we've got to take a look at the volume that unit actually takes up. So each conductor entering or leaving the box, 1, 2, 3, 4 conductors. Bare bonds do not count. The 1 moret does not count. So now we're just looking at the 4 conductors, and they are number 14s, right? So we're going to take the 4 number 14s, and we're going to go to the other table. Let me bring that up. So that we're going to have to go to table 22. Number 14s on table 22 take up 24.6 milliliters each. So that's why we can see here that we've got 4 number 14s, so 4 times 24.6 milliliters gives us a total of 98.4 milliliters for the conductors. And now we have to find the milliliters for the taken up by the GFCI. The GFCI is 4.1 centimeters in depth, and the rule tells us that we have to multiply that by 32 centimeters cubed. So we've got 131.2 centimeters cubed for the GFCI. Now centimeters cubed and milliliters are equal values there, 1-to-1 ratio there. So we can say centimeters cubed, or we can say 131.2 milliliters. Okay, total occupied space is the 98.4 for the 4 conductors, plus the 131.2 for our GFCI, giving us a total of 229.6 milliliters. And then once we've gone to there and find our total there, we're gonna have to go to table 23 again. And now we're looking for a device box. We're looking for number 14s, and we're looking for a device box that's going to accommodate a specific amount of volume now. So now we're here in this column for capacity in milliliters, and we're looking for a total of 229.6 in our device. And so if we scroll down here, 204 is not going to do it. This is the size of the box, minimum size box that we can use. So we're going to have to use a deep box for that GFCI. We're going to have to make use of a 3x2x3 device box. And that device box can accommodate 245 milliliters. We're looking for something that can accommodate 229.6. So this is well within the reason to have this particular GFCI fitting into this 3x2x3 device box. Okay, so a little bit different than the previous one. We have to find total milliliters taken up for volume for all of our conductors. Then if we have any morettes, which we don't, we just have the single morette, which counts as 0. We would have to multiply that by the largest size volume. And then we have to accommodate the GFCI. And we have the depth of the GFCI, 4.1 centimeters times 32 centimeters cubed. And then we add up the conductor's volume and the GFCI column volume to find our total occupied space. Then we go to table 23, go into this column, and find a volume that matches or exceeds the value that we're looking for. Okay, so hopefully everything's making sense so far, guys. Let's take a look at the next example. So example number 9, we've got a 2-gang device. This one, it hasn't been ganged. It comes as a solid unit here. So we're told that the volume of this guy, it's a 3 by 3¼ by 2½ device box. And on the cut sheet for this one, it gives us a capacity of cubic inches of 25 cubic inches. Okay, so we're going to have to find the total number of 14 conductors that can actually fit into this box. You'll be surprised at the number that actually fits in here. So again, stop the video for a second, see if you can find the answer, and then we'll bring up the answer in 3, 2, 1. Okay, so we're going to table 23, guys. First we have to do a conversion. So if you look at page 32 of your code book, you'll find the conversion table. Let me bring that up right here. Give me 2 seconds. Okay, so we can see here on page 32 of the 2024 code that the multiplier for cubic inches or divisor for cubic inches to cubic centimeters is 0.061. So our next steps here, using this value here, 0.061, so we're going to take the 25 cubic inches that we're given, divide by 0.061, and that's going to give us a total of 409.84 milliliters of capacity. So that's our capacity in milliliters for this 2-gang box. We know that from table 22, let's bring that up, give me 2 seconds. Okay, so we know from table 22 that number 14s take up a volume of 24.6 milliliters. So we'll take the 409.84 milliliters that 2-gang box accommodates, divide by the 24.6 milliliters for each number 14, and that gives us 16 number 14s that can fit into this 2-gang box. Okay, obviously the question is a little bit misleading. It's just asking for the number of 14 conductors that can fit into this box, but we've obviously got to take into account any morettes that are going to be in there, and we've also got to take into account any devices that are going to be in that 2-gang box as well. Okay, let's take a look at the next example here, guys. Number 10, determine the size of octagon box to accommodate 4 number 12s and 4 number 10s. Okay, so now we've got 2 different gauges of wires in this box. On the previous examples, everything had all been the same gauge of wire. Okay, so let's take a look at this guy. And again, with this one, there's no bonding wire being provided. In this case, we're just assuming that the bonding is done with the EMT, the metal box, and the EMT on the other side here. So we're just looking at these 2 number 10s, these 4 number 10s, these 4 number 12s, and then these 2 pairs of morettes there. So let's stop the video here, see if you guys can figure out what to do in this case, right? Based on the previous examples, in that we have 2 different gauges of wire. So if you go to table 23, there is no column that says 10s and 12s. So you got to go to table 22 and then use 22 to find something in 23. See if you can figure that out, and then I'll bring up the answer now. Okay, so let's take a look. We got 4 number 12s, right? So each conductor coming in and out is going to have to be multiplied by 28.7 milliliters. Where do we get the 28.7? The 28.7 is right here in table 22. Okay, so we're using, let's erase the number 14s here. So the number 12s are 28.7 milliliters each. So we've got 4 of those guys. So that gives us a total of 114.8 milliliters for our number 12s. For the number 10s, there's 4 of those guys as well, right? So we've got 1, 2, 3, 4 number 10s. And if we take a look at the volume that those guys take up, number 10s are going to take up 36.9 milliliters each. So 4 times 36.9 milliliters gives us 147.6 milliliters for the number 10s. Okay. Next thing we're going to do is we're going to obviously add up those values. Oh, we gotta keep track of the Moretz, right? We got 4 Moretz, so that's 2 pairs. So we've got to make those 2 pairs now count as 2 conductors, right? 2 conductors of the largest size. Largest size is number 10. Those number 10s are good for 36.9. So 2 times 36.9 milliliters gives us 73.8 milliliters for the Moretz. So don't forget the Moretz when doing the total volume required. So now we've got our total required. 114.8 plus 147.6 plus 73.8 gives us a total of 336.2 milliliters. And now we're going to go to table 23. And in this case, we're looking for an octagon box, right? So we need 336.2. We're in octagons. And we need 336. Looks like there's only 2 standard sizes of octagon boxes that are provided here. So the one that we're going to have to go for is the 4 by 2 1/8 octagon box, which has a capacity of 344 milliliters. Okay, so we're looking for 336 milliliters for the 12s, the 10s, and the Moretz that are counting as 2 10s, and total is 336. And so obviously this octagon box of 4 by 2 1/8 is going to accommodate the 336 because it has a total volume of 344 milliliters. Okay guys, next example for number 11. We've got the same example as before, right? If we go back to this guy, number 10s and number 12s, but now we have bonding conductors. These are insulated bonding conductors. So we're going to have the 4 number 10s, the 4 number 12s, we're going to have 5 Moretz, and then in terms of the number 12 bonding conductors, number 12 bonding conductors are sized for the number 10s here. We have 1, 2, 3. Remember that conductors coming in or out of the box, if they're insulated, are going to count for box fill, but this little pigtail does not count whatsoever. Okay, so we got 4 number 10s, 4 number 12s, and then 3 additional number 12s for our insulated bonds there. So we'll you guys stop the video here, see if you can find the size of octagon box to accommodate this, and we'll see whether we need a larger octagon box. There was only 2 on the previous example when we looked at table 23. So let's see whether that 4 by 2 1/8 will still accommodate these guys now that we have these insulated bond conductors. Okay, so we've got the 4 number 10s, right? So that's 4 times 36.9. Again, the 36.9 is coming from here, from table 22. Okay, then we've got 7 number 12s. So 7 number 12s were from the 5 Moretz, the 7 number 12s are the 4 current carrying conductors and the insulated bond conductors. So those are our 7 number 12s. We've got to multiply that by 28.7 for the number 12 gauge. And then our Moretz, we got 5 of those guys, which is going to count as 2 pairs of the largest conductor, which is 10 gauge. So 2 times 36.9 gives us 73.8 milliliters. Okay, we're going to add up all of these guys. So we got 200.9, 147.6, and 73.8. We've got a total of 422.3 milliliters. Now, when we look at table 23, we can see that the largest box that's provided here is a 4 by 2 1/8. It's only good for 344 milliliters, and we need 422. So what we're going to have to do is we're going to have to make use of an extension ring, guys. So we'll make use of one of these guys, right? So this one will have to be bonded as well, right? So we'll have to bring another bonding pigtail to bond this guy. And so what we're going to do is we're going to put this in, and it's going to give us an additional amount of volume based on whatever size the extension ring is. So when we look at table 23, this one was good for 344. So we could put a 4 by 1.5 inch extension ring on there, right? Because the 4 by 1.5 inch octagon box has a value of 241, right? So 241 plus our 344 is going to be well in excess of the 422.3 milliliters that we're looking for there. Okay, so don't be a donkey and put 3, 4, 5 extension rings on. One extension ring is the max you're going to use out in the field. But in this case, it's perfect because when we look at table 23, that 4 by 2 1/8 didn't provide us with enough volume for all of those number 10s, number 12s, and the Morettes. So having our initial box plus a smaller extension ring provides us with enough volume and enough airspace for everything to keep cool, and nothing to get pinched within the box or the extension ring. Okay guys, so hopefully everything's working out so far. You've seen a number of examples, and this one I tried to trip you up in that the amount of volume that was required was not here on table 23. But keep in mind you can use extension rings to increase the volume of your boxes. Okay, let's look at the final example here, guys. Okay, final example is we're going to look to see whether a 4 by 4 by 4 junction box is going to accommodate these guys. When we look at table 23, we can see that, here, let's erase what's on here. We can see that on table 23 that there is no 4 by 4 by 4 box, right? These are all just standard device boxes, octagon boxes, square boxes, masonry boxes, and then FS boxes. So it doesn't have anything by a 4 by 4 by 4, but we've got the skills here, and that we've looked at the previous examples, find our total volume. We can find the volume of this box and then the volume of these conductors and Morettes that are required, and then see whether the volume of this guy can provide these, can provide enough room for these guys. So we're not going to make use of table 23, but we're going to use the same skills that we looked at in the previous examples there. Okay, so let's take a look. On this guy, we've got a conduit coming in. We're going to have 11 number 12s. They're going to be T90s coming in. And we're going to have a number 14 bond wire coming in. Okay, so again, the bond is based off of the number 12s here. And then we've got a 1/2 inch conduit here where 4 of those conductors are going to go straight through, and 1 of the bonding conductors. And then on this 1/2 inch conduit, so this is most likely a 3/4 coming in, and then 2 1/2 inches coming out. On the 1/2 inch here, we're going to have 4 number 12s. So those 4 number 12s are going to come from these joints. And we're also going to have that number 14 bond wire in that pipe as well. Okay, so over here, we're going to have 7 number 12s, T90, and a number 14 bond. In this EMT, we're going to have 2 going straight through and then 3 joints. And we're going to have to keep track of all the Morettes that we have here as well. Okay, so I've provided the totals over here on the left-hand side. So we've got 6 number 12s going straight through. Okay, so 4 here and 2 in this pipe. We've got 12 number 12s going in and out. So all these joints right here and here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 in and out. And those are all, that takes care of all of our number 12s. And then in terms of the number 14 bond conductors, we've got 1, 2, 3 conductors that come in and out. This little pigtail that goes to bond the box does not count. So we have 3 number 14s, and then we have 7 Morettes. 1, 2, 3, 4, 5, 6, 7. Okay. Keep in mind that when you do your pairs of Morettes and find the total number of conductors, that they're going to correspond to the largest size of conductor being the number 12. Okay, so find the total volume for the number 12s, the number 14s, and then for the Morettes, and then see whether the 4 by 4 junction box is going to accommodate all of those guys. Okay, I'll bring up the answer in a couple of seconds. Okay, so first thing we need to do is go to table 22, right? So table 22 is going to tell us our volumes for each of the conductors. So we've got number 12s and number 14s, right? So the number 12s are going to take up a volume of 28.7, which we're seeing right here. and then the number 14s are going to take up a volume of 24.6, okay, which is seen right here. And keep in mind that the 7 barrettes, which is 3 pairs, is going to correspond to the large conductor of number 12s. Number 12s had 28.7 milliliters. Okay, so let's walk through our total capacity here. So we've got 18 number 12s, which is right here, 6 plus the 12, giving us 18. 18 times 28.7 milliliters gives us 516.6 milliliters of volume for the number 12s. We got 3 number 14s, so 3 times 24.6 gives us 73.8 milliliters. And then we get 7 barrettes, which is 3 pairs. We've got to go with the large conductor of number 12, so 3 times 28.7 milliliters gives us 86.1 milliliters for the barrettes. Okay, now we're going to add up the 516.6, 73.8, and the 86.1 to give us a total volume required of 67.6, I keep doing that, sorry, 676.5 milliliters total. Now, keep in mind that I asked you about 4x4x4 box, but if we look at table 23, what do we need? We needed 676.5. So we can see that the largest square box, 411/16 by 2 1/8, that can actually accommodate all of those guys, right? We need 676, and this has 688. A little bit tight, but it's still, by code, it still would be fine. 4x4 would definitely provide us with enough volume because we can see that the 411/16 is good. But let's go through the math just to show you that the 4x4x4 is actually going to work. So in this case, we've got our total volume of 676.5 milliliters required. We're going to find our total volume of the 4x4x4 box. So 4x4x4 gives us 64 cubic inches. And then on page 23, we had that conversion, right? So we're going to take the 64 cubic inches, divide by 0.061, and that gives us a total capacity in that 4x4x4 box of 1,048.77 milliliters. Okay, now obviously that's way above the 676. We've already seen that the 411/16 box had enough room for all of these guys. So obviously a 4x4x4 box is going to be ample. But here we can see with the math that the milliliter capacity of the 4x4x4 box is 1,048, well within the volume required of 676. Okay, or you could do like the cubic inches. We need 64 cubic inches, and 676.5 multiplied by 0.061 gives us 41.28 cubic inches. So well within the 64 cubic inches of the 4x4 box is going to accommodate the 41.28 cubic inches for our number 12s, number 14s, and the barrettes there. Okay, so hopefully everything's made sense, guys. Those are all the examples that I have for you. Give me any issues that you found in the video. Tell me if the volume's good. Tell me if the pace is good, and tell me whether the way that I'm presenting the material is working for you. All right, guys. Thanks very much, and we'll see you guys on the next video. Thanks for all your patience.